Hello, this is Mr. McLeod, and this is going to be a little demo covering references, objects counting, and strings and string literals. So we're going to start here with how do you compare references versus contents? In other words, when is it going to compare whether two objects are the same object versus when is it going to actually look at the contents of the object? So like with a point, if we make a point here that is x is 3 and y is 5, then we make another point where x and y are also 3 and 5. If we say 0.1 equal 0.2, is that going to return true, saying that they're both 3, 5, or is it we're going to return false? And the answer to this one is that it's going to return false because P1 and P2 are two separate objects. And we can see that if we were to make a diagram of what's going on here. Basically, we've got P1, this variable, and we say new 0.35. So that basically creates a new point object that has the values 3, 5 stored for x and y. And P1 is basically a reference variable that is referencing this object. Okay, and the fact that it says new here is what tells us it's going to be a new point object. So that means when we make P2, this is also going to be a new object because this also has the new keyword here. So then this is also going to be another object that happens to have the same values for x and y, but it's a different object. Okay, if we were to say where in memory are these stored, let's say this is like stored in memory slot A, and this is stored in memory slot B, memory address, right? So you have some address that's unique for each object. And really the data that each reference variable stores is just the address where that object can be found. Okay, so then because you can see that P1 and P2 do not point to the same object, then P1 is not equal to P2. If you did want to compare 2 point objects and decide whether their x and y values are the same, we could go look at the point class and see, is there a method that does that? So let's click here, go to the point class. See, I've got my thing set up a certain way. Let's do this here. All right, so if we go to the point class and we scroll down here, you can see that there is a method called equals, and this method will return true if the object you pass it here is a 0.2D object and has the same x and y as the object that you call equals on, right? So if you said some object dot equals some other point object, if the x and y's were the same, then they would be equal, right? Okay, so let's go back here. So that means if we wanted to write an alternative version. All right, so then we could say P1 equals P2, and this would be true. If we wanted to print it, I guess system.out.println P1 dot equals P2. This would actually be true because both points have X and Y values of 3 and 5. Now notice that this is only true because the point class happened to have an equals method. If we go back here to the equals method, you'll notice that one of the things you may notice is that this takes an object rather than a point, which might have seemed a little surprising to you. However, check this out. It says this overrides the equals in class point2D. So let's follow the trail here. So if we went to, see if I write this, oh yeah, this takes me straight to the equals method in point2D, which in turn says it overrides the equals in the object class. So we could click that, and here we are. We scrolled all the way up to the top. You can see we're in the object class now, right? And every object actually turns out has this equals method. And that's why it takes an object, right? Because it's going to return whether any two objects are equal. Now, if we look at this, there's a whole bunch of information here about how if you do override this method, you need to make sure that it works basically the way people would expect it to work, so that the objects are reasonably considered equal. I'm going to clear this, clear all these drawings. Okay, but then if you look down here, this says that unless, by default, if this method implemented in the object class simply returns true if the objects are equal, right? This all just says essentially it's true if and only if X and Y refer to the same object, right? Which is exactly what equal does. So it's only useful to use the dot equals method if the class of the objects that you're trying to compare actually implements that method, overrides that method in a way that's useful so that you can actually tell if they contain the same content, right? Because what does that even mean, right? Like the same content is going to mean something different for each class. So it turns out the point class does override it, and also the string class overrides it. And you're going to see here in just a second how the string class works. Okay, so I'm going to erase that. Okay, so back here, we're on this line now. So string A equals high. So if we were going to draw a diagram of this, I'm going to just do the same kind of thing that we did before. So we've got A is pointing to some object that says high. Now, actually, I'm going to do this one. Well, I'm going to do this one a little bit different. I'm actually going to draw over here this thing, place in memory, we'll call it the pool. And this is basically the string pool, where in Java, strings are a little bit special and very special, actually. There's all this special syntax for them. And because they have this syntax where you can make a string literal, okay, a string literal is any string that has, any string that's just in the quotes, right? So like you literally write what it says. So anytime you create a string literal, it gets saved in this pool of strings. And so if you use the same literal multiple times in your code, it's going to keep referring to the same object rather than making a new object every time. So far we have a string that says hi in the pool. And so that means string A, this reference variable, is actually going to point to that string, right? So it's going to point to the string that's in the pool. And when we make string B, that is also going to point to that same string because it's another literal that says the same thing. Okay, so all literals that say hi in quotes are going to be pointing, any reference to them is going to point to the same object. All right, and then string C, though, has this new keyword. So string C is actually going to make a new object over here in memory. And it's going to say the same thing. It's going to say hi. And because we've already created a string that says hi in the string pool, that means this string right here that we're passing into the constructor does not have to be created, right? It already exists. But then because we said the new keyword here, it still makes a new, this is explicitly making a new instance of string that's going to say the same thing as whatever gets passed in here. Okay, so then, all right, so basically A is going to point to this one. All right, so now if we just analyze the diagram, so this is kind of the key to doing these problems of figuring out, like how many objects are created, how many are accessible, which ones are equal. All of that is much easier once you have this diagram. Then it basically, the diagram says it all. So A equal to B, that's going to be true because A and B, you can see, are pointing to the same object. B equal C is clearly not true because B is pointing to this hi that's over in here in the pool, whereas C is pointing to this other object that was created when we said new string. So they are not equal. All right, so that's it for this slide. And we're going to go on to the next one. Okay, so we talked about this a little bit just now about how to tell when new objects are created and are accessible. And previously we were making these diagrams, but we were just looking to see what was pointing to what so we could tell whether things were equal. Oh, whoops, you know what? I forgot to answer this last question. So A was equal to B. Just going back to well, I can't get the picture back, but that's okay. But remember that B was not equal to C. And just like with the point class over here, we can just say system.out.println B dot equals C. That will be true if B says the same thing as C. And you can confirm that if you go to the string class, you'll see that just like with point, it has an equals method. Let's find it here. It's in alphabetical order. So here we go. There's equals. And if we click on that, you can see that this overrides the equals in the class object, and it's going to return true if the argument is not null and is a string object that represents the same sequence of characters as this object, right? So basically it says the same thing. All right, now we're ready to go to the next slide. Okay, so when are new objects created and accessible? So just like in the last slide, the answer to this is all in the diagram. If you just draw a picture of what's happening, then we can answer these questions. All right, so let's start with point A. We have point A is a new point that has values 3, 5. And we'll say A, oops, A is, I'm going to just use these arrows. A is 3, 5. Okay, and then B is a new point and they're passing it A. So if we were to go look at the point class, it probably would not surprise you that that is making a new point that is like a copy of whatever point you passed in. So you can see here, that's this constructor, right? It's going to initialize a point with the same location as a specified point. Okay, so the important thing here though is that you're using the new keyword. So each time you say new, it still makes a new point. So it's not going to just point to the same one, it's going to be a different one, right? So we can say over here, B is going to point to this new object that still has the same X, Y, 3, 5. All right, and then we say point C is going to be another new point object. Okay, so we made a new point object, and then it's created by making another new point object, which is at 3, 5. So you can see each time we said new, that was another one. They're all 3, 5. And then C is just pointing to the one, the first new here, right? So new point made from this new point. This actually, notice that in the end here, like actually just straight from the beginning, there is no reference variable that ever points to this new point, right? It's like we used it to pass it in as a parameter, but we never actually stored it anywhere. There's a special name for that. This is called an anonymous object, okay? Because it's an object that we created and we used it, but we never stored it in any reference variable. So it's like used and then immediately trashed, right? Like used and then it immediately becomes garbage because there's nothing pointing to it and there never can be anymore, right? You don't even have a way to access it anymore. Okay. And then finally, they're going to say D equals C. So when we do this, point D is just equal to C. That means they're creating a reference variable that's just pointing to this existing object. The same, whatever object C is pointing to at the time, D will also point to that same object. So there's actually a special name for this situation too, which we didn't mention before, which is that you could say at this point, D and C are both aliases of that point, right? So basically, an alias is like another name for an object, right? So whatever we say, like let's say the memory address of this is FA6 or something, right? Like this object has two aliases, C and D. It's kind of like if your name was Ted, but your birth name was really Theodore, you just went by Ted all the time, then you could say that Theodore and Ted are both aliases for the same person, right? For you. Okay. All right, so we've got D equals C, and then there's a bunch of these where we're setting different variables. C equals A. So in this case, at the time that we initialized D, C was pointing to this point with an address FA6. I'm just going to give each of these an address like A63721 415. I'm just like making up unique addresses for them. Okay, so then that means if C equals A and A is pointing to the point object at 721, then C will be pointing to that now instead of the one it was pointing to before, right? But D is still pointing to FA6, right? So that one still, it still exists. It's not garbage yet. Only 415 is garbage so far because nothing, that was the anonymous object that nothing ever pointed to. Okay, and then we've got B equals A. So then that one also is going to replace the reference so that B, instead of pointing to A63, is going to be pointing to 721. All right, so now at the end here, they're asking first A equal B. That's going to be true because A and B are pointing to the same object, the one at address 721, right? And then A equal D, that will be false because D, you can see here, is pointing to the object at FA6, but A is pointing to this object at 721, so they're not the same object. So that is false. Okay, and then the number of objects created, since every time we created an object, we just drew, we put it in our diagram, then we can simply count how many objects were added to our diagram, and that's how many were created, right? So we can see there's 4 objects created, and the number of objects accessible is simply how many objects have a reference variable pointing to them, right? Because the ones that don't are no longer accessible, right? Because how would we even reference them? So you can see that this one right here, A63, has nothing pointing at it anymore, so that is garbage. And this one was the garbage right away, right? Remember, this was the anonymous object. So this also has nothing pointing to it, so it is garbage, leaving only 2 of them, 721 and FA6. Those are the only 2 objects that are not garbage because they still have variables pointing to them. So there's 2 of those. Okay.